So another question that we are going to work on as part of revision on our static and dynamic balancing. This is April 2024 exam, just a basic question that we are going to quickly look into. All right, I have done a similar question like this on our introductions. This is a condition where you are balancing a single mass, all right, balancing a single rotating mass. So take note, you're balancing what? A single rotating mass, which is definitely part of our static balancing. So, yep, I had this question because of some errors that were on this part, but guys, there was a pulley with a mass of 0.03 grams. This is too small, the mass here. It was supposed to be 0.03 megagrams. All right. Here's its center gravity of 12 centimeters from the axis of rotation. The pulley is carried in the center between, all right, take note here. The pulley is carried in the center between what? Two bearings that are 800 millimeters apart. All right. I have talked about this. I'm not going to waste your time, guys. Let us have the pulley. It has the mass of 0.03 megagrams. Convert this to kilograms. Remember, mega, that's times 10 to the exponent of 6. So, and kilograms, kilo, that's times 10 to the exponent of 3. 10 to the exponent of 3. So it means this was going to be 0.03 times 10 to the exponent of 3 times 10 to the exponent of 3. So that is, this one gives us times 10 to the exponent of what? 6. The product of these two. But, sorry, here we we do not have kilograms here. We do not have kilograms. It is just grams. It is still grams. So what I need is to take this 10 to the exponent of 3 represents what? Kilo. So that's a kilogram. So it means the mass was going to be, just multiply these two. 0.03 times what? 0.03 times 10 to the exponent of what? Of 3. So that was going to be 30 kilograms. 10 to the exponent of 3 means what? Kilo. So it's now kilograms. So that was just an error on the value. And also for this one, but as for this one, guys, I failed to check the value. I'm just going to use this one as it is, but this is too much. The speed that you're given there, it is wrong, this one. Unless they wanted to change something. It was actually, I don't know. But let us just use this, all right? So this is the mass that we're going to use. At least it can make sense, all right? So given what the radius, this is the radius from the axis of rotation, all right? Yes, its center of gravity from the axis of what? From the axis of rotation. So that is our radius. So that is our radius, 12 centimeters. Convert to meters. 1 meter, remember, it is 100 centimeters. So 12 centimeters, simply divide by 100. That's 0.12 meters. All right, that's our radius of the pulley. So we're given that it is taken, or it is to be placed, it is to be carried in the center, in between what? In between two bearings. So it is going to be taken on the center like this. All right, so this is going to be our pulley in between where these two bearings are separated 800 millimeters apart. So that is the idea that you're going to have. So this is on the left, and this is the one on the what? On the right. So that is divide by 2 because it is at the center between, it is at the center. So we've got equal distance, 400 and 400 this other side. So remember, I explained that when it is like this, you can simply use forces to answer this question. So on this pulley, you definitely gonna need the weight of the pulley. All right, you're gonna need the weight as it is facing down. So the weight from the mass, that's what? Mass times gravitational acceleration. 30 times 9.81 gravitational acceleration. That was going to give us 294.3 Newton. So that's it, 294.3 Newton. So this is basically from the information that we are given. That is what it means. So here it is now. We are now asked to calculate the following 7.1. That is the static load, all right, on each bearing. So the static load on each bearing, these are the reactions of what of the supports from the two bearings. Where I said from the introduction, you can use the moments, apply the moments, or you can simply apply the what, the forces, since RL is equal to RR, it is in between. So you can simply use sum of forces. All right, sum of what, forces going up must be equal to sum of forces what, going down. So what is going up? Those are the two reactions. So if you add RR plus RR, RL plus RR, these two, they are the same. So it's same as what, RR plus, I mean RL plus RL, which is 2 RL, which is equal to what? The ones that are going down, the force is facing down, that is the weight. So it's supposed to be equal to W, the weight. So that is it. Calculating RL is calculating what? RR. So that is the idea. So simply RL is equal to the weight. We have already calculated this, 294.3 over 2. So that was gonna give us 147 147.15 Newton. And this is the same as what? This is the same as RR, the one on the right. So that is the static load on the what? On each bearing. Then 7.2, the out balance force if the shaft rotates at 600 rads per second. Guys, this is too much. The angular velocity that we are given there is too big. But anyways, this is how you calculate the outbalance. This is the centrifugal force. Remember, that is what? Your centrifugal force. So simply they are asking you to calculate that centrifugal force. That will be the out of balance. Remember, for a single mass, you're going to have another here and another on the other side. So that's from the mass and radius, and that omega, it's mass times radius times omega squared. So that's the mass, 30 kilograms, the radius in meters, 0.12 times our omega. This is too big, 600. So it's going to be 600 squared. They just made a mistake on that value. But anyways, you're just going to use as it is. And for this one that I corrected here, guys, under exam, use the value that you had, that you were given under exam. That is what you're given. But here, it was going to be something else. So that's why I had to just change that one. But use the value that you're given. So it was going to be 129,600 Newton, which is too big, this value. All right. Anyways, let us convert to kilonewton. That's going to be 1296 kilonewton at least. That can, we can work with this one. So this is our out of balance force. All right. Then not forgetting this, the maximum and minimum load on the bearings. All right. So remember, I told you guys, because of what? Due to unbalance, we are going to calculate, we are going to have different what? Load on the bearing. So that's the maximum and what? And the minimum. So to calculate this, all right, guys, I gave you the formula for this. 7.3 R max, which is the maximum, is taken from the centrifugal force over 2. Then we're supposed to add any of these two, R or RL, because they are just the same. So plus RL. Remember, we calculated this. So since our FC, our centrifugal force, is in kilonewton, let us also convert this one to kilonewton. All right, converting this to kilonewton, that's going to be divided by 1000. So it's going to be 0.147 kilonewton. So you're going to just use kilonewton and kilonewton. You see there, that's why I was saying that value is wrong. You're not supposed to go through such for proper values. But anyways, for what we have, let us do this. 1926 in kilonewtons divide by 2. We're going to add RL in kilonewton, 0.147. So that's, we are going to have 648,147. It will be already in what? In kilonewtons. So this is the maximum, whereas the minimum, simply subtract this time. So the minimum, that was going to be FC over 2 minus RL. So that is the that is it between these two guys. You're done. 1296. You see, it's a repetition. We dealt with a similar question like this, only that the issue of the values, the values, they were just going to change values, but mostly they are going to ask this question in this manner. So just do revise. Just do revise. Like I said, also go through the introductions so that you understand all the basics and other questions also that you can expect to have under balancing a single rotating mass. So you're talking about what? A single rotating mass. So that is it. Let us do revise as many questions as we can as we are preparing ourselves for the exams that are ahead of time.